Up to this point, it's been a little difficult to solve when we have unknown exponents. I guess at this point, though, we can take and solve this by sliding the base to the other side so we can get x by itself because we know how to bring that power down. And we get log base 5 of 7 equals x. What power of 5 is equal to 7? It's too hard to tell without a calculator. And even on a calculator, you're going to need some tricks for that. So we know it's about 1 point something. It's definitely not 2 because that would be 25. But typically in mathematics, they'll ask you to solve in terms of common logs, which is basically log base 10, right? So if I want to solve this problem using common logs, the way I'll do it is as follows. Anytime you solve an equation, you got to make sure that whatever you do to one side of the equation, you do to the other side. So what we're going to do is take the common logarithm of both sides of the equation. And now using the properties of logarithms, I can bring that x to the front. And then if I want to isolate the x, I just divide by the log of 5. So again, I don't know how much better this is here than this over here. It's just we've solved it in terms of the typical quantity that books and mathematicians typically are going to ask for. So in terms of common logs. But we do know this. We know that the log base 5 of 7 was equal to x, and this x is also equal to the log of 7 over the log of 5, which brings about something else.
And that something else is what's called the change of base formula. Change of base formula says if I have the log of a base q of a p number, that can be changed to an equivalent of the log of any base you want of that p over the log of any base you want over that q. But the key is the two bases have to have the same base. All right. Now in a problem like this will come in handy because A, we don't have any formula for multiplying two logs of different bases, let alone even two logs of the same base. So in this case, I can change this into something more recognizable. Now, the base you're probably most comfortable with is log base 10, so let's just do that for kicks. We'll go the log of 3 over the log of 2 times the log of 32 over the log of 3. Now, notice what just happened. These reduce, leaving me with the log of 32 over the log of 2, which is not, by the way, the log of 16. However, if I can look at this and see that it's in this form, I can go back to this form. So note, this is equal to the log base 2 of 32. And I know what power of 2 is 32? 5. Problem done. Now, again, we can pick the log of any base we want. All right. So if I did the following, for instance, let's say I choose this time to use a different log base. And I'm going to go the log base 2 of 3 over the log base 2 of 2 times the log base 2 of 32 over the log base 2 of 3. Notice log base 2 of 3s are still going to go, and what I have left is what power of 2 is 2, that's 1. What power of 2 is 32, that's 5, and I eliminate a step. So it's all about choosing a base that's going to work nice, and it's a matter of what you see rather than actually picking the right base, because any base is the right base. It's just what will make it a little easier to do.
So now we're going to go ahead and do some solving using, they give us a choice, either natural or common logs. I'll just use natural this time. It doesn't really matter unless you have the log base e or the log base 10, and I don't have either in this case. So I'll take the natural log of both sides. I'll bring that x plus 1 to the front. I'll have the natural log of 3 and the natural log of 84. There's a couple ways you can do this. I'm going to take and distribute this through, and I'll tell you why in a minute. I have x log 3, or natural log of 3, sorry, plus the natural log of 3 equals the natural log of 84. I get the x term by itself by subtracting the natural log of 3. And then I want x by itself, so I just divide. And I get this quantity. Notice I can't reduce this because I have a subtraction here. However, I can probably simplify this a little bit more. I know that 3 goes into 84 evenly, all right? And that's just going to be a total of 28 times. So I can say this is, I'll do it in a couple of steps. How's that? Natural log, because I have a subtraction, I can turn that into a division over the natural log of 3. So this is the natural log of 24 over the natural log of 3 as a solution. And that's about as simple as I get in this case. Again, I cannot reduce the 24 and the 8 because these aren't multiplications. This would be like saying, oh, I don't know, that's not a good example. Let's just put it this way. You can't say this is equivalent to the natural log of 24 over 3. No go. You could only do that with the subtraction. So that's our final answer. All right. Similar problem, but there's some, added confusion in here with all this kind of stuff. I still want to isolate the base first in this case. So what I'll do is I'll take and bring the 12 over by subtracting, get me 32. And then I'll divide by 4. So I now have my base isolated. And actually, this case, I could use common logarithms or natural logs, but it's probably easier to just say, well, hey, that's just 2 cubed, and this is 2 to the x plus 5, and I know that x plus 5 is equal to 3, and x equals negative 2, and I'm done. This problem, you're going to have to use common logarithms or natural logarithms to solve. Since, again, I don't have a base 10 or a base e, I'm going to use natural log, just because it's one less letter to write. So I take the natural log of both sides. I, again, will bring that x plus 5 out in front. Now this x comes out here. Suppose there's a little bit of a problem. I'm going to need to get all the x's to one side. So I'll distribute this and get x natural log of 7 plus 5 natural log of 7 is equal to x natural log of 2. Get all the x's to one side. And we're at this point. Now I got to get x by itself. The only way to do that is to factor in this case. So this is a natural log of 7 minus the natural log of 2. And this is negative 5 natural log of 7 over ln 7 minus ln 2. And unless I really want to get a complex fraction and say this is the natural log of 7 halves, and then this is the natural log of 7 to the negative 5. This is about as simple as it'll go, so we'll take that as an answer. Now in this case, I definitely want to use natural logarithms because I have base e. And let me show you why that's convenient. The first thing I'm going to do is isolate that base of e by dividing 3. Then I'll take the natural log of both sides. Four x plus 5 will go in front. It's a natural log of e, and this is the natural log of 11. I'm going to bring it over here just for a minute. If I have the natural log, that's the same as log base e of e. What power of e is e? This right here is just 1. So we continue with the problem, and we have 4x plus 5 equals the natural log of 11. And basically, that'll be the natural log of 11 minus 5 over 4 for my solution. And finally, this doesn't look anything like what we've been doing, but it actually is. It kind of looks like we've got 3 terms, so this could be a disguised quadratic, and it actually is. Notice what I can do here. I can state that 4 to the x is the same as 2 squared to the x, which is the same as 2 to the 2x, which is the same as 2 to the x quantity squared. So notice 2 to the x quantity squared plus 2 to the x minus 12 equals 0. Now, if I haven't already convinced you that that's a quadratic, let's do this. Let's say, put a happy face in there and say that equals 2 to the x. If that's the case, then this is the happy face squared plus the happy face minus 12. And if you can't see that's a quadratic, then there's a problem. All right, so we've got happy face, got a 4 and a 3. 4 is going to be positive, 3 is going to be negative, so I get a value of 3 and negative 4 for the happy face. But again, I'm not solving for that happy face. What I'm trying to solve for is x. So let's go right over here and say, well, 3 is equal to 2 to the x, and negative 4 is equal to 2 to the x. Immediately I can say this is extraneous because no power of 2 is going to give me a negative number. And then if I want, I can slide the base here and get the log base 2 of 3 is equal to x. And if they wanted it in common log form or natural log form, I can just change the base on that. So this is also equal to the log of 3 over the log of 2. And either way is fine. But this is basically a substitution into a quadratic. And that's all we have until next time.